Alright, welcome to 7-7, distance from a point to a line. I feel like I'm Doctor Who in the TARDIS trying to time travel. I'm preparing this a week before I leave for a short trip to Washington State. But anyway, let's get going on this. I put a warning here because the textbook talks about how we get the formula first for to solve a problem that we actually have been doing since Algebra 2. And that problem is, what is the distance between a point and a line? And if you remember, going back even as far as geometry, we talked about that distance between a point and a line to always be the perpendicular distance. So we want that to be our distance. And to do that, there was a method that we worked on in Algebra 2, and sometimes it would be more than one problem. But we actually, there's a 5-step process to find this, given this information here. And this is example 1. So if you open up your books, you'll see the new method and how fast and easy it is compared to what we're about to do. I'm going to pause throughout this when I do the calculations. For right now, don't worry about taking notes. You just want to be able to follow and make sure you understand this. And so if there's a confusing step, why don't you ask the teacher to pause, and then you can help each other out to figure out what I just did. First thing is to find the slope of the line. So we're right here, and the slope of this line right here, not the point because there's no slope there, but we have a line and we need to find the slope. And remember, y equals mx plus b is the slope-intercept form of the line. So I really want that m, and in order to get that, I could subtract 8x over, so I'll have y equals minus 8x plus 20. The 20 is over there, and I got to divide by 5 at the same time. And so this new equation becomes negative 8 over 5x plus 20 over 5. But really all I cared about was the slope, which is negative 8 over 5. The second thing I do is find the opposite reciprocal of that slope. And so to do that, I just take the slope that we just figured out, and I'm going to say that's positive 5 over 8. And so double check, I subtracted, that got me my negative, divide by 5, and then I flip it and make it positive. So we're pretty good there. Now we have a slope and we have a point. Now the slope is this line right here. It has to be perpendicular to it, and we don't have an equation for it, but we have a point that lies on it. That's the 4, 5. So I'm going to rewrite that here, and hopefully you remember y minus y1 equals m times x minus x1, and that's the point slope form of a line. And so we could put that in y minus y1, here's your x and y, so that'd be y minus 5 equals 5/8 times x minus 4. Now I'm going to pause and you'll see the solution here, but you pretty much have to distribute the 5/8 through and then add 5 over. So hold on. Okay, so you should be able to see that now as y equals 5/8 x plus 5 over 2. Now that's the equation of that line right here. So the intersecting, if I intersect these two lines, I get that point. And that goes to a problem where we had like 8x plus 5y equals 20. And then you have y equals 5/8 x plus 5 halves. And sorry about that. Plus 5 halves. And we're asking to find the solution of that. And so we're now on step 4. This green part was step 3. And so there's different methods that we learned in our class to solve for this. I would just quickly remind you of substitution. Equals 20, and then I'm going to go ahead and work this out, pause it, and then just put the solution here. So you'll see it in a half a second. Okay, so if you worked it all out, you would see x equals 60 over 89. We're getting some ugly fractions here. but they'll all simplify out. And again, if you're trying to do it yourself, I made a bunch of mistakes and had to redo this a couple times. So just be really careful. Go slow. And again, this is your Algebra 2, and maybe you could consider first semester pre-advanced math 2 as the methods that we use to solve this. So now that I have x, I need to plug that back into either equation in here to get y, and I'm just going to go ahead and solve it as I pause. Okay, so we get y equals 260 over 89. At this point, you then have a problem where you're given 2 points and find the distance. And so we have our point that we started with, 4, 5, and then we have the point 60 over 89 and 260 over 89. And then we use the distance formula. Distance equals x2 minus x1 squared plus y2 minus y1 squared. And once we plug that in, then we will have our answers. Okay, so I'm going to pause here, do the work, and you'll see it appear. Okay, so as you can see, we plug everything into the distance formula, and I went ahead and did 60 over 89 minus 4, squared it, and just to give you an approximation here, 11.06. Likewise over here, you get 4.32. You add those up, take the square root, and you get 3.92. But going back to what we're actually working on here, this is an ugly problem. It's hard. Even for an Algebra 2 advanced pre-calculus, even a calculus student most likely would forget how to do it or make mistakes as they go through. But luckily, we now have a new formula. And what I want to do on that formula is just go ahead and start with it again. I'm not trying to show you how to do it. I'm going to show you that next. And just briefly, you don't need to worry about trying to figure out how we get the formula, just being able to use it. And every time we use it, I want you to write it down. So we're going to have d equals ax1 plus by1 plus c over plus or minus the square root of a squared plus b squared. And I make mistakes on this all the time. I actually had to do a problem like 4 or 5 times because I kept on putting the x in for the a and the y in for the b and messing this up. So you got to be really careful that you have ax1 plus by1 plus c over here. The other thing is this plus or minus really doesn't matter because distance is always positive. What happens is that plus or minus is dependent more on you get it from what c is, but that plus or minus is dependent more on where the line and the point is relative to the origin. And you could look in the book just real quick. If you look at pages, I think 464 to 465 or 470. I don't have my book open. I wrote this down earlier to explain it, but you'll see why we bother about the sign. But for the most of the rest of this lecture, I'm not going to worry about that. So this formula, which is going to give us the same answer as this up here, is really simple. You got to put this in y-intercept form, and we have ax plus 5y minus 20, not y-intercept form, standard form. And so your a equals 8, your b equals 5, and your c equals negative 20. Now that negative would mean that we have a positive here is the opposite. But again, that we just worry about that because it's where it is in respect to the origin, and I'm not going to go into that. And so to solve this, we just go 8 times x1. Here's our x and there's our y. So 8 times 4 plus b, which is 5, times 5 plus c, which is negative 20, all over the square root of a, which is 8 squared, plus b, which is 5 squared. And again, you would put the positive out here, but it doesn't matter, because on the top you're either going to have a positive or negative, and you're either dividing, getting a negative or a positive. And the answer, even if it's negative, the distance is still positive. That's confusing, but when we do problems it'll make more sense. But so you do the math up here. I'm going to pause, do the math, and you'll see it. Okay, so there we go. If you do the top, you'll get 32 plus 25 minus 20. That becomes 32 plus 5, or 37. 8 squared plus 5 squared is 89. And then when you finally do the math, you'll get approximately 3.92, which is exactly what we got before. But we did this much math instead of all of that. And so it's a nice formula. It's one of those things where it's like, why didn't they teach us that before? Well, the reason is because of this. In order to show you how it works, we had to see the normal form of a linear equation. And this was in our last section, which again, I feel like Doctor Who time traveling, because we haven't covered this yet, but I'm pretending that we did, because you have. You should have covered this 2 days ago. But then again, that's 6 days from now, or 7. I'm just so confused. Anyway, they'll show you this picture here, or something that looks similar to this, and they'll get you to this point right here, and then what happens is that the distance equals the normal form of the line. But the normal form of the line, you could include the two known coordinates, or the point x1, y1, and then when you plug that all in, cosine theta, sine theta minus p, all of that is equivalent to here, which is, I think that's where, if you go to page 464, 465, that's what we will cover on Wednesday in my time, but in your time that was 2 days ago. And you'll hopefully remember this right here. And it's because of all that we could now do this problem here with minimal math compared to having to do all of that junk that I did at the beginning. So now let's go ahead and just focus on solving these using the method that we now have. And again, in order to memorize this, like when I see 12 here, I'm going to go ahead and write the formula. Distance equals ax1 plus by1 plus c all over plus or minus the square root of a squared plus b squared. You want to write that down. That will help you memorize it. You want to remember why we have a plus and minus, why we worry about it, but at the same time, if you're just solving for distance, we don't really care if it's plus or minus, or even if the top is minus, because it'll all work out. So I like to go ahead and make sure I write the x and the y here. Make sure I have a, b, and c. This is already in standard form, so we don't have to worry about it. And so we can just plug it right in. This is 5 times 3 plus, now b is negative 3, and then y is 5. The tricky part is making sure that you don't drop a negative or something when you have it. And all over plus or minus the square root of a, which is 5, so that's 20, a squared, so that's 25. B is negative 3, and then that's still going to be positive 9. And so I'm left with that. I'm going to pause and give the answer. Since c is positive, then this would be negative. And again, I keep on telling you I'm not going to worry about that, but I keep doing it just because I have to. Okay, so I'm going to pause and give you the answer. Okay, so after you put it in, you get here. It's nice that 15 minus 15 cancels out, and you got 10 over negative root 34. This is where I drop my negative because I'm not really worried about it. The book will have you rationalize the denominator, and they'll give you this answer here. So if you're practicing this and doing some extra odd problems, you'll see this answer right here. You could give me a decimal, but if our test is multiple choice, you'll see this answer. If you get the test that you calculate the answer, you'll get credit for this. You'll also get credit for the decimal where you should have gotten 1.7. as a distance if you multiply that out. Let's look at 14. So here is 14, and again you have x, y. Now this is y-intercept form or something like it, and sorry for this, I wanted to type it out, but you have y equals 4 minus 2/3 x. So if you multiply everything by 3, 3y equals 12 minus 2x, then move the x over, you have 2x plus 3y minus 12 equals 0. You now have it in standard form. So there's your A, there's your B, there's your C. And again, you write out this formula, and every time you use it, it will help you memorize it. And even though you might use a note card or a page of notes, you want to be able to know the formula quickly and easily. And so A is 2, x1 is -2, plus B, which is 3, and y, which is -3, and C we got as -12. Most important thing is double check your positive and negatives. That's where I keep making mistakes, is I forget one or I write it down incorrectly. A is 2, so that'll be 4, plus B, which is 3 squared, so that's 9. And I'm going to pause here. Every time I go down here, there's a pause button. So I'm going to pause here and do the problem. Okay, so from here we would get this, -4 minus 9 minus 12 divided by positive root 13. Root 13 because it's negative C, but again I drop that over here. Top works out to be -25 over root 13. When you rationalize the denominator, there's a little mistake there. It's not an 11, it's a 13. You should get that as your answer. So let's do another one, and you probably already know this. Pause if, ask the teacher to pause if I'm going too fast. So x and y is here. Again, you are in y-intercept form. We need to go to standard form. I like to just clear the fractions first. So I multiply everything by 3, that gives me an 18. 3 times 6 is 18. I add the 4 over. 3 is already positive. Subtract the 18, I get equal to 0. So there's my A, B, and C. And now let's write the formula. D equals A. I know it's getting tedious that we keep writing it, but I can't tell you how important it is to make sure that you commit it to not only your memory but your muscle memory. And you have A squared plus B squared here, and then let's go ahead and put everything in. So A is 4, B, or x1 is -1, plus B, which is 3, times y, which is 2, plus C, which is -18. And then if that's negative, we could just leave this as positive. A squared is 4 squared, or 16. B squared is 3 squared, or 9. And I'll pause and then put the answer. Okay, this one worked out to be 16 over 5. You can see how you get the top, -4 plus 6 minus 18 over square root of 25, which equals -16 over 5. But since it is a distance, we don't care about the negative. All right, let's keep going. I don't know how many times you've paused or not, so class could be getting close to the end. I have 2 more problems. They're no different in using the formula. However, you're given 2 lines, and so let me show you a really quick trick on here. You just need one of these lines. You need a point on a line. I'm going to choose the top one, and I'll use this line. So if I want to point on that line to make it easier for me, I'm going to make sure I select 0. If I go y equals 0, I get 6x equals 3. That means x equals 1/2. So now I have a point 1/2, 0, and that line. So there's my x and there's my y, and my a, I'll go ahead and rewrite this and move over, add the 5 over. So I got my a, b, and c, and there's no difference. So given two lines, what's the distance between two lines? And they have to be parallel. These are parallel, same slope. Two parallel lines, the distance, you pick a point, and if possible, which should be almost every time, but not, doesn't have to be, but y equals 0 could be on that line, and you just plug it in, or x equals 0. And so let's go ahead and write our formula. D equals ax1 plus b y1 plus c, all over plus or minus the square root of a squared plus b squared. And so a is 6, b is, or x1 is 1/2, plus b, which is minus 8, times 0, so it'll drop out, plus c, which is 5. And then since that's positive, we would write the negative, even though I keep telling you I'm not going to worry about it, but I do it anyway. 36, and then 8 squared is 64. And so I'm going to go ahead and do the math and pause here for a half second. Okay, so you get 3 plus 0 plus 5 over the negative square root of 100, so you get 8 over negative 10, but we drop the negative because we don't care about it when we talk about distance, and you get 4/5 as your answer. And then now we're moving on to the last problem. So you might want to, oh no, there's 2 problems. I was wrong. We got 2 problems left, 20 and 22. I'm looking at 22 minutes into this, so there's a good chance that you guys don't have time for both of these. So I'm going to keep recording, and this will be available on my website if you need it. Here I would say let's make x equals 0, so y would be equal to 1, because if I put a 0 in for here, that cancels out, and you got y equals 1. And then if we use this line right here, we have the point 0, 1, so there's my x and there's my y. This is almost in standard form. Gotta subtract the 2 over, but I have my a, negative 1 is my b, and there's my c. So distance equals a x1 plus b y1 plus c, all over plus or minus the square root of a squared plus b squared. Hopefully you can do that in your sleep by now. Let's see, a is 2, x is 0, that cancels out, plus b, which is negative 1, times 1 for y, and then plus negative 2 for c, and we're going to plus or minus the square root of, and that's negative, so that would be positive. So a squared, 0 squared is 0. Oh, I almost made a mistake. I did this so many times before. I chose my x to be 0, not my a is 2, so 2 squared is 4. B is negative 1. Negative 1 squared is 1, so that's going to be plus 1. Again, going to pause and give you the answer in half a second. Okay, so you get 0 minus 1 minus 2 over negative 5, root 5. So that's equal to negative 3 over root 5. Drop the negative, rationalize the denominator, and you'll see 3 root 5 over 5. Alright, last problem that we have, 22. Come back here, please. Okay, so again, same thing. We have to pick a point on one of these lines. I'm going to pick x equals 0, so y, if that's 0, y equals negative 1. And then you just go ahead and put that with the other line. So my x is 0, my y is negative 1. I'll rewrite this out. Subtract 5y over, plus 15 equals 0. You have your a, you have your b, you have your c. we rewrite our formula here, and that's going to be over the square root of plus or minus a squared plus b squared. And so let's plug it in. A we figured out was 8, x is 0, plus b, which is negative 5, times y, which is negative 1, plus c, which is 15. All of that over the square root of, it would be negative since that's positive, but again, we don't have to do it, but I can't stop myself. It's like rinsing the dishes right before the dishwasher. I can't help myself. And hopefully you laughed at that. Okay, I'm going to pause. Alright, so you do the math here. You get 0 plus 5 plus 15 over the negative square root of 89. So that will become 20 over negative 89. We don't worry about the negative, and we rationalize the denominator to get this. So that's it. Thanks for tuning in or paying attention in class. And I can never get in these videos with anything witty that I want to say, right? And it's too late because I'm not going to re-record this, so I'm just going to press the stop button. Have a great day. Bye.